Hello everyone, welcome back to my Inspire Logic show. In today's video, we are going to learn about one of the most important concepts in lean manufacturing, the Toyota Production System, also known as TPS. So, however you wonder how Toyota is able to achieve high quality, low cost, minimum waste, and faster production. The answer is the Toyota Production System. So in this video, we will understand what is TPS and is the main principle and the two important pillar of the TPS and how we can apply the concept in the lean manufacturing industry. So one by one, I will discuss about in everything. So let's start about this. So first of all, you told what is TPS. TPS means the Toyota Production System. So the Toyota production system is a comprehensive production and management system developed by the Toyota in the manufactured product. In the manufactured product efficiently, consistently, and high quality. It focuses on elimination of waste, creating continuous flow, producing according to customer demand, preventing defects, and solving problems at their root causes, and continuously improving process while respecting people. So TPS is one of the main foundation of TPS. So TPS is one of the main foundation of what is now widely known as lean manufacturing. So definition of the Toyota production system. The Toyota production system can be defined as a production system designed to achieve the highest possibility quality, lowest possibility cost, and shortest possible lead time by eliminating waste and continuously improving processes. TPS is not simply a collection of manufacturing tools. It is completely way of thinking about production, quality, people, machine, material, information, problem solving, management, continuous improvement. The system is designed around two fundamental ideas. Just in time, the system is designed around two fundamental ideas. Just in time or JIT or Jidoka. These are supported by the standardized work, continuous improvement, respect for people, production leveling, visual management, problem solving, and many other practices. And see, this is the history of the production system. The development of the TPS took place over many years. So Toyota began as company associated with the textile machinery and before becoming one of the world major automobile manufacturer. So major figure in the development of the TPS was Kitsuno Toyota and who emphasized producing vehicle efficiently according to the actual demand. Another extremely important figure was Tichuno, who developed and implemented many of the concepts, became central to the Toyota production system. And Singo also made an important contribution to manufacturing improvement, including concepts related to quick changeover and mistake proofing. So after World War II, Japan faced limited resources and a difficult economic environment. So Toyota could not simplify a copy of the large-scale American mass production model. So large-scale production company relied on very large batches and a large inventory, long production run, large equipment, significant storage, separate inspection activity. In that time, Toyota needed a system that could produce many different vehicle models while using fewer resources. This leads to important question. How can we produce high quality vehicle efficiently when resources are limited and customers require different products? The answer is gradually developed in the Toyota production system. So main purpose of the TPS is the primary objective of the TPS often are assumed as high quality. Main purpose of the TPS is first one is high quality produce product correctly and prevent defects. Low cost, eliminate activity that consume resources without creating value. Low cost, short lead time, reduce the time between receiving an order and delivering the product. Reduce the time between receiving an order and delivering the product. That is the short lead time. High productivity, use people, machine, materials and time effectively. Customer satisfaction, deliver what customer wants when they want it and the required quality. Employee development, and develop employee as problem solver, improvement contributor. So the Toyota Production System House. The Toyota Production System House. TPS is commonly represented as a house. So the house alarm showing the pillar of the system are connected. So simply represented by Toyota Production System. Customer satisfaction, high quality, short lead time, low cost. So just in a product. So first one is just in time. That is the two main thing. One is the just in time, another one is the Jidoka in Toyota production system. Just in time product, what is needed, when it is needed, and in the needed and it is needed quantity. And Jidoka build quality into the process. And stable and standard the process. Standardized work in Joka 5 years standardized work means in Joka 5 years TPM visual management, continuous improvement Kaizen, respect for people. This is the exact Toyota works illusion varies depending on the source, but the central idea remains the same. The two main pillar of the TPS, the two main pillar of the TPS, the two main pillar of the TPS. So first one is just in time. So the two main pillar of the TPS is one is just in time, another is Jidoka. Just in time. So the just in time means producing and delivering the right item in the right quantity at the right time. So the right item in the right quantity and the right time. The goal is to avoid unnecessary inventory and overproduction. Jidoka means building quality into the process of stopping when an abnormality occurs. The purpose is to prevent defects from continuing through the production system. So just in time, fully explained in just in time. So just in time is one of the most famous concepts associated with TPS. So traditional manufacturing may work like this. So produce large quantity, store products, wait for demand, sell product later. TPS attempt to move towards customer demand, production signal, production, delivery. And the objective is to reduce unnecessary inventory while maintaining reliable production. The three element of the just in time. So just in time can be understood through three basic ideas. First one is takt time. What is takt time? The rate at which product need to be produced to meet the customer demand. Second one is continuous flow. Product should move smoothly through the production instead of the spending excessive time waiting. Pull system. Production should be triggered by the downstream demand rather than simplify producing large quantity in advance. Takt time. So takt time connects production to the customer demand. Takt time connects production to customer demand. The basic formula is Q. Takt time equal to available production time divided by customer demand. Available production time divided by customer demand. For example, available production time for 20 minutes per day. Customer demand 210 units per day. So therefore, takt time equal to 420 divided by 2 minutes per unit. So the production system therefore need to complete approximately 1 unit every 2 minutes to satisfy demand. Takt time is not necessarily the same as the cycle time. So cycle time, the takt time is not necessarily the same as the cycle time, because what is cycle time? So the cycle time is the actual time required for process to produce one unit. For example, takt time equal to 2 minutes, cycle time equal to 1 minute. The process can potentially keep with the demand. But if the takt time is 2 minutes and the cycle time is 3 minutes, and the process cannot produce quickly enough to meet demand, so this indicates capability or process problem that needs to be addressed. Pool system. What is pool system? Pool production. What is pool production? TPS emphasizes a pool system. A pool system means the downstream consumption creates high signals. So wait 1 second. So in pool TPS emphasizes a pool system. A pool system means the downstream consumption creates a signal for a upstream replenishment. For example, customer final assembly consume component signal to previous process replenishable component. The trends, while the pure pool system where every department produce according to their own schedule, regardless of what is the next process actually needed. That is the pool system. Because one by one, we can clarify about that in every system. Kanban. So what is Kanban? So Kanban is one of the method used to support pool system. Kanban provides a signal that tells a process what to produce, how much to produce, what to replenish, when to replenish, where the material should go. So Kanban can take different forms. So Kanban can take different forms. First, so many forms: cards, container, labels, electronic signal, production order, digital system. The main concept is not the card itself. The important concept is production and replenishment are controlled by clear demand signal. That is called Canva. So another topic is Jidoka. What is Jidoka? Jidoka is the second major pillar of the TPS. It is sometimes described as a automation with a human touch. Automation with a human touch. The deeper principle is that abnormal conditions should be detected immediately and the process should stop when necessary. Instead of defect occur, keep proceed and defects occur, keep producing, and hundred of defects, inspection defect, discover problems. Discover problem. The TPS aims to the TPS aims to abnormality occur, detect immediately, stop process if necessary, investigate, correct cause, restart. And why the Jidoka is important? Why Jidoka is important? If a defective part continues through several processes, the cost of the defect increases. So, for example, incorrect part, assembly incorrect, painting incorrect, final assembly incorrect, inspection incorrect, reward. So, that is the main concept of the Jidoka. The company may have to spend significant time and resource processing a defective product. So Jidoka tries to identify the problem as closer as possible where it occurs. And is a visual or audible. So the Andon is a visual or audible signalizing system used to communicate abnormal condition. For example, green normal, yellow, attention required, red, problem or stop. So a worker may active as a hand signal when they encounter a problem. This means problem visible to supervisor or support personnel. The purpose is not to blame the worker. The purpose is main abnormality visible so they can be solved quickly. Then quality at the source. Quality at the source. So traditional quantity system may depend heavily on the final inspection. Traditional quality system may depend heavily on final inspection. TPS emphasizes build quality into the process itself. So this means the person or the process performing the work is responsible for producing a correct result. For example, instead of waiting until 1000 products are finished before checking them, the process should detect abnormal condition as early as possible. This reduces rework, scrap, customer complaint, warranty cost, production interruption. That is the quality as the source or not once you check it. Another one is Pokayoka. So Pokayoka means mistake proofing or error proofing. The objective is to design a process so that the incorrect action is prevented or immediately detected. For example, suppose a component can be installed incorrectly. A mistake proofing feature might allow the component to feed only in the correct orientation instead of depending entirely on a human memory. So worker remember correct orientation. The process is designed to help current orientation fit. Incorrect orientation does not fit. So this is improve quality. Then waste muda. So one of the central concepts in the TPS is muda, remaining waste. Waste is an activity that consumes resources but does not create customer value. TPS focus heavily on identifying and eliminating unnecessary activity. The traditional 7 waste are waiting, transportation, overprocessing, inventory, motion, defects. So commonly used in lean framework also identify an 8 waste. Another waste is unused human talent. Unused human talent. So one is then overproduction. Another is overproduction means producing one of the most cost-of needs are earlier than the necessary. Overproduction means producing more than the customer needed or earlier than necessary. Example, customer demand 100 units, production 200 units. The additional 100 would may require storage, handling, inspection, space, capital, production. Overproduction is particularly dangerous because it can hide other problems. Then another is waiting. So waiting occurs when the worker wait for material, machine wait for operator, products wait for a processing, production wait for approval, customer wait for delivery. Example, a machine complete a process in 30 seconds, but then waits 5 minutes for the next process. The 5 minutes waiting period is form of waste. In transportation. Transportation is unnecessary movement of materials. Example, warehouse, machine A, storage, machine B, storage, assembly. So repeated transportation does not transform the product. TPS therefore tries to design efficient the material flow and over processing. Overprocessing means doing more work than necessary. Example, excessive polishing, unnecessary inspection, producing tighter tolerance than required, and repeating work using overly complicated procedure. And the key question is that does this activity create value that the customer needs? That is the matter. Inventory. Inventory includes raw materials, work in progress, finished good. Excessive inventory can hide problems. For example, large inventory production problems remains hidden, no immediate pressure to solve it. When the inventory is reduced approximately, problems can become more visible. However, reducing inventory blindly is not the goal. The system must remain stable and capable of meeting customer requirement. And motion. So motion refers to the unnecessary movement by worker. Example: working unnecessarily, searching for tool unnecessarily, reaching repeatedly, bending unnecessarily, looking for materials. Good workplace design reduce unnecessary motion. And another one is defects. So defects are error that cause a product. Defects are error that cause a product or service to fail requirement. Defects creates scrap, rework, inspection, delay, customer dissatisfaction, warranty cost. TPS emphasizes preventing defects rather than depending on only the file and inspection. Unused human talent. Another one is unused human talent. Employee process experience, technical knowledge, creativity, problem solving ability, process knowledge. So if an organization ignores employee idea, it loses an important source of improvement. TPS therefore emphasizes developing people and involving them in a problem solving. And another one is Mura. So Mura means unevenness or inconsistency. Example: unevenness or inconsistency. Example: Monday 100 units, Tuesday 500 units, Wednesday 50 units, Thursday 600 units. This creates unstable workload. Employee, machine, and supplier may experience alternating period of extremely pressure and low activity. TPS attempt to reduce this unevenness through production leveling or better planning. And Muri means overburden. Overburden occurs when the people or equipment are expected to perform beyond reasonable capability. Example: excessive overtime, excessive workloading machine, unrealistic production requirement, poorly designated work. Overburden can lead to reduced defects, accident. Overburden can leads to defect, accident, fatigue, machine failure, employee dissatisfaction. Then relation between Mura, and Muri. These three concepts are closely related. Mura means unevenness, Muri means overburden, Mura means waste. For example, uneven customer demand may create production peak. Production peak can overload worker or machine. Overload process can create defects, breakdown, or delays. These programs can additional waste. Then another topic is Kaizen. Kaizen means continuous improvement. Kaizen emphasizes making improvement continuously rather than waiting for one large transformation. Improvement can involve safety, quality, cost, delivery, productivity, workplace organization, machine reliability, material handling, employee experience. A Kaizen improvement may be a small. For example, a worker work 10 meter to obtain a tool. The tool is modified next to the workstation. The working distance is reduced. A small improvement can become the significant when the repeated hundred of times are per day. PDC. PDC means Plan to Check Act. Continuous improvement is commonly supported by the PDCA cycle. PDCA means Plan to Check Act. Plan, identify the problem and plan solution. 2. Implement and test the solution. Check, measure the result. Act, standardize the successful solution or modify approach. Then the cycle begins again. Plan to check act and plan again. This creates continuous improvement. Then standardize work. Standardized work means establishing a consistent method or performing a process. Established work means a stabilized work means establishing a consistent method for performing a process. It generally consider work sequence, required time, standard inventory, quantity requirement, safety requirement. For example, step 1 pick component, step 2 position component, step 3 install component, step 4 tighten fastener, step 5 inspect, step 6 move product. Standardization provides a baseline for improvement. Without a standard, it becomes difficult to know whether a change actually improved the process. And standardize and improvement. And standardization and improvement. TPS follows an important cycle. Current standard, improve process, better method, new method, improve again, new standard. Therefore, standardization does not prevent improvement. It creates the foundation for improvement. And another topic is 5Ps. So 5Ps is a workplace. A 5Ps is a workplace organization method commonly associated with the lean. The five stages are sort, means remove unnecessary item, set in order, so arrange necessary item so they are easy to find or use it, sign, clean the workplace and equipment, standardize, create the standard to maintain the condition, sustain. Maintain discipline and continuous follow the standard. IPS not simply about cleaning. It purpose to make the workplace organized, efficient, safe, visual, and easy to manage. And visual management. What is visual management? Visual management makes the condition of a process understandable quickly. So example includes color coding, floor marking, production board, and underlight, leveling, standard work display, workman's board, wiring scene. The idea is it make normal abnormal condition easy to see. Another topic is that Hinjuka. Hinjuka means production labeling. Hinjuka means production labeling. Hinjuka means labeling production. Suppose demand changes significantly. So Monday 100 units, Tuesday 30 units, Wednesday 50 units, and Thursday 250 units. Producing exactly according to these large fluctuation can create instability. Production labeling attempt to smooth the workload where practical. Benefit can include more stable workplace workforce requirements, better supply planning, lower inventory, reduced overtime, better machine utilization, more stable production flow. So one piece flow. So one piece flow means moving product to the production with minimum batch accumulation. Traditional batch production 100 units, process A 100 units waiting, then process B, then 100 units waiting, the process C. So flow oriented production unit 1 A to B, B to C, unit 2 A to B, B to C, unit 3 A to B, B to C. The one piece flow can reduce. See, one piece flow can reduce work in progress, inventory, waiting, lead time, defect propagation. You know what is lead time? Lead time is the total time required. Lead time is the total time required from the beginning of the order or the producing process until completion and delivery. Conclude material waiting 2 days, processing 3 hours, inspection waiting 4 hours, finished good waiting 2 days, and transportation 1 day. The actual processing may only take 3 hours, but the total lead time is much longer. TPS looks the way to reduce the time product spent for waiting. Then value added work. Then value added work. Value added Value added work transform the product in a way that the customer requires. For example, welding required components, installing an engine, painting according to the specification, assembling required parts. Non-value-added activity can include waiting, unnecessary movement, excess transportation, excess inventory. The objective is to maximize value-added activity and minimize unnecessary activity. Then Gyanbutsu. Kenji Campus is commonly transported as go and see actual place and actual situation. That is called Gemba work. So instead of making decision only from reports, our manager should understand what is actually happening and where the work is performed. For example, a report say assemble productivity has decreased rather than immediately blaming worker. A manager goes to the production floor and observe. They may discover material shortages, tool problems, poor workstation layout, machine interruption, quality problems. The actual situation provides better information for problem solving. Then Gemba means the actual place where the work happens. In manufacturing, this often production floor. Going to the Gemba means observing the process, people, equipment, material, quality, flow, problems. This objective is to understand the reality rather than relying only on assumption. And 5 the 5 why technique is to use investigate root cause. The 5 why technique is to investigate root cause. Example problem machine stopped. Machine stopped. Why the motor overheated? Why the motor cooling was insufficient? Why the cooling filter was blocked? Why the filter was not clean? Why there is no defined cleaning standard? So the investigation moves from the immediate symptoms towards the deeper process cause. The number five is not a strict requirement. The important principle is to continue asking why until the underlying the cause you don't know that the answer is correct or not. Suppose that answer is correct or problem solved, it is understand significant to prevent the occurrence. And root cause analysis. What is root cause analysis? TPS focus on solving the root cause and not merely fixing the immediate symptoms. Suppose defective products are being produced. A weak solution might be inspect more product. A stronger approach is why it is defect occurring. Then investigate machine condition, material, method, measurement, worker instruction, environment, maintenance, process design. The goal is to make the process more reliable. Problem solving in TPS. A typically problem solving process can be uh, identify the problems, identify the problems, go and see, understand the current situation, set a clear target, analyze the root cause, develop countermeasures, implement, check result, standardize, continue improving. Respect to peoples. Respect to peoples. Respect for people is a fundamental part. Respect for people is a fundamental part of the Toyota philosophy. Employees should be treated as people who can think, solve problems, learn, improve processes, develop skill, contribute ideas. The purpose of Lean is not simply to make employee work harder. Instead of it should make work safer, easier, more consistent, more productive, less wasteful. Then involvement. Employee working directly in a process. Employee working directly in a process often understand problems that are invisible to senior management. For example, a operator may know this machine takes 5 extra minutes for adjust because the picture is difficult to access, and that information can lead to process improvement. Therefore, TPS encourages employees to participate in improving activities, total productive maintenance. So, reliable equipment. Reliable equipment is too essential for TPS. The production system cannot achieve smooth flow if the machine frequently break down. Maintenance activity may include preventive maintenance, inspection, cleaning, lubrication, and condition monitoring, operator involvement, planned replacement of core components. The product line manufacturing field commonly uses total productive maintenance (TPM) to improve equipment reliability. SMAD and changeover reduction. When a machine changes from producing one product to another, it may require a setup time. For example, product A, machine setup, product B. If the setup takes 2 hours, manufacturer may produce very large batches. If the setup time is reduced, smaller batches become more practical. SMAD, single minute exchange of die, is a methodology associated with reducing setup or changeover time. Benefit include smaller batches, lower inventory, greater flexibility, faster response to demand, faster response to demand, and better flow. And supplier relationship with TPS. TPS does not treat supplier simple as source of these cheap materials. Suppliers are the important partner in the production system. Important areas include quality, delivery, reliability, cost, technical capability, problem solving, communication, continuous improvement. If supplier repeatedly deliver defective or late material, the production system cannot operate smoothly. Therefore, supplier development and collaboration are important. Production flow. Production flow means moving material to process smoothly. Production flow means moving material to process smoothly. A good flow minimizes waiting. A good flow minimizes queuing, unnecessary transportation, excess inventory, unnecessary handling. For example, material process 1, process 2, process 3. Inspection customer. The closer the process is to continuous flow, the less time product spent for the waiting. Then line balancing. What is line balancing? Different workstations should be balanced according to the required production weights. So line balancing, different workstations should be balanced according to required production weights. Suppose the required takt time is 4 minutes, but the workstation takes say 2 minutes, and workstation B takes 8 minutes. A takes 2 minutes, B takes 8 minutes. Then workstation B is bottleneck. So the system cannot maintain the required rate unless the process is improved, divided, combined, or otherwise adjusted. Line balancing attempt to distribute work more effectively. Then bottleneck. What is bottleneck? A bottleneck is a process that limits overall production capacity. For example, process A 100 units per hour, process B 100 units per hour, process C 50 units per hour, process D 100 units per hour. Then process A is constrained. So producing more at A does not necessarily improve total output because B and C cannot process the additional material. TPS therefore focus on the overall system flow rather than maximizing the output of evenly individual machine independently. Manufacturing formula. Manufacturing example. Imagine a factory producing automobile doors. The process is sheet metal, stamping, welding, painting, assembly, inspection, delivery. The factory discover discovers large quantity waiting between process, worker waiting long distance, defect discovered only at the final inspection, long machine changeover, frequent equipment breakdown, production based on the forecast rather than the actual consumption. TPS principle can be applied. Applying TPS to the example. Problem 1. Excess inventory. Introduce better pool control or reduce unnecessary access size. Problem 2. Long waiting. Long working. Applying work organization and improve workstation layout. Problem 3. Defects. Introduce quality at source. Practice and mistake proofing. Then long changeover. Applying changeover reduction method. Problem 5. Machine breakdown. Improve maintenance. Uneven production. Apply production labeling where appropriate. Unknown root cause. Use structural problem solving and root cause analysis. TPS and customer demand. TPS and customer demand. The entire system begins with the customer. The company must understand what customer want, how much they want, when they want it, required quality, required specification. Production should then be designated to respond appropriately. The basis relationship is customer, demand, tact, pull, flow, quality, delivery, quality, delivery. So TPS and cost reduction. TPS and cost reduction. TPS reduces cost primarily by eliminating waste rather than example creating cutting resources. For example, instead of reducing worker by 10%, TPS asks why do the workers spend so much time waiting, packing, searching, correction defects, or handling materials? If those waste are eliminated, productivity can improve without simple using employee workload, TPS and quality. Quality is treated as something that happens only at the end. Quality should be built into the process. Repeated idea include Jidoka, Pokayoka, standardized work, root cause analysis, and employee problem solving, continuous improvement. The objective is to prevent problems instead of repeatedly correcting them. TPS and safety. So a stable production system must also be safe. Lean activity should not encourage unsafe speed, excessive workload, poor ergonomics, ignoring hazards, bypassing safety procedure. A process that is fast but unsafe is not successful production system. Then TPS and people development. TPS consider employee development part of the production system. Employee can develop through training, standardized work, problem solving practice, coaching, teamwork, improvement activity, cross training. The objective is to create people who can identify and solve problems independently. TPS and management system. TPS is not only factory floor method, it is also affect management behavior. Manager needs to go to the management system. Manager needs to go to the workplace, understand the process, ask questions, develop employee, solve problems statistically, establish standards, monitor performance, and support continuous improvement. Management should create an environment where the problems are visible or improvement is expected. Traditional versus TPS. Traditional versus TPS. Traditional approach, Toyota production system. Production large batches, produce according to demand. Keep large inventory, minimize unnecessary inventory. Find defects at the end. Defects and prevent defect early. Hide problems, make problems visible. Push production, pull production. So large changeover, reduce changeover time. Workflow instruction only. Worker participate in worker follow instruction only. Worker participate in improvement. Fix symptoms. Find root cause. Minimize local efficiency. Optimize total system. Improvement is occasionally. Improvement is continuous. The five fundamental questions of TPS. TPS can be understood by asking five questions. What does the customer value? Understand customer requirement. What does the customer value? Understand the customer requirement. What creates the value? Identify activity that actually transform the product. And what prevents smooth flow? Identify waiting, inventory, bottleneck, transportation, defect, unevenness. What happens when the program occurs? What happens when a program occurs? So detect it quickly, stop when appropriate, and solve the root cause. So how can the process become better? Use Kaizen and continuous improvement. So complete the TPS example. Imagine if active produces Imagine if active produces 500 sales per day. The process wood cutting, drillings, standing, painting, assembly, inspection, packing. The company has several problems. So the problem one, cutting produces 100 units per day. Customer demand is only 500. So that create overproduction. Problem 2, work long distances to get tools. This creates unnecessary motion. Problem 3, paint defects are discovered during final inspection. This creates defects and reward. Problem 4, assembly frequently, wait for components. This creates waiting. Problem 5, the drilling machine takes 1 hour to change between products. The drilling machine takes 1 hour to change between products. This encourages large batches. TPS improvement to the chair factory. TPS improvement to the chair factory. Improvement 1, production according to the demand. Production according to the demand. Reduce unnecessary overproduction. Improvement 2, workplace organization. Apply 5 years and place tool closer to the worker. Improvement 3, quality at source. Investigate why painting defects occur. Improvement 4, pool system. So use replenishment signal to control component supply. Improvement 5, changeover reduction. Reduce drilling setup time. Improvement 5, standardize work. Document and train the best known process. Improvement 7, Kaizen. Continue searching for additional problem and improvement. What makes the TPS different? What makes TPS different? TPS is different from simple using individual lean tools. A company can use Kanban, 5S, Kaizen, Pokayaka, visual management, and still the fail to create a true lean system if underlying management philosophy is missing. TPS is system. The part must work together. For example, standardized work, stable process, pool system, flow, problem becomes visible, problems becomes visible, problem solving, Kaizen, better standard, improve process. That is the roadmap. The main principle of the Toyota production system. The major principle can be summarized as customer focus, understand customer value, waste elimination, remove activity that do not create value, just in time, produce what is needed when it is needed, Jidoka, build quality into the process, flow, keep work moving smoothly, pull, produce based on actual consumption, standardize, create stable method, Kaizen, continuous improve, respect for people, develop and involve employee, root cause problem solving, solve problems rather than repeatedly treating symptoms, visual management, make condition and abnormality visible, production leveling, reduce unnecessary unevenness. Benefits of TPS. Benefits of TPS. When implemented effectively, TPS can contribute to improved quality, fewer defects, and better process control, lower inventory, less unnecessary metal or work in process, reduce lead time, produce move through the system more quickly, lower cost, less waste, and deliver better productivity. Resources are used more effectively, Improved flexibility, smaller batches and faster changeover can improve responsiveness, better employee involvement, employee participate in the solving problem, better customer satisfaction, products and deliver with the required quality and timing. Challenging of implement TPS. Challenges of implementing TPS. TPS is not easy to implement. Common challenges include the resilience to change, employee or manager may prefer existing method, lack of management commitment. Lean cannot succeed if leadership treat as a temporary project. Poor standardization. Without stable process, improve becomes difficult. Using tools without understanding principle. Simple installing Kanban board or doing 5S does not create TPS. Lack of improvement, employee involvement. Improvement is difficult when the employee are not included. Focusing only on cost. Excessive cost cutting can damage quality, safety, and employee capability. Inconsistent problem solving. Problem must be solved systematically rather than repeated patches. TPS is a long-term philosophy. So one of the most important thing is to understand is that TPS is not a one-time project. It is not. Implement lean for 6 months. It is long-term management philosophy. The cycle is standard, problem, analyze, improve, standardize, new problems, improve again. Continuous improvement never really ends. So final summary of TPI Toyota production system. The Toyota production system is a integrated production and management system developed by the Toyota to achieve high quality, low cost, short lead time, and strong customer value. The most important idea just in time, Jidoka, Kaizen, standardized work, pool system, pool production, Kanban, tactile, continuous flow, one phase flow, Injuka, 5 days, Pokaka, Andon, 5Y, Genju, Ganbitsu, Gemba, changeover reduction, maintenance, respect for people, waste elimination, root cause, problem solving. At the end of the center TPS is simple principle. Understand the customer needs, create value, eliminate waste, and make problems visible. Solve problems at their root cause. Standardize successful improvement and continuously improve while respecting people. The two major pillars are just in time and Jidoka, while Kaizen and standard work respect people, productivity leveling, and problem solving, providing the foundation that allow the system to operate effectively. Ultimately, TPS is not just about producing car faster. It's about building a stable, efficient, high-quality system that continuously learn and improve. That is all about the TPS. So this is my part 1 video, and part 2 video I will explain that in that PDF. So one by one I will explain it. And this is my Toyota production system PDF. So let's see that image. You can clearly understand about this TPS system. So see that is the image. You can clearly understand about that. Whatever I previously explained about that, that is all the information in that PDF full there. You can check. So civilization, what is TPS Toyota production system? This is the owner of the Toyota production system, and that is the main two topic is that just in time and Jidoka. That is the two Toyota production system main important two things. And we will explain that house of the Toyota production system. See that image. And this is the Toyota production system. And this is my part 2 video, and part 3 video I will explain that in what is in principle in the Toyota production system. This is my part 3 video. So part 3 video I will explain important principle in the Toyota production system way. So past principle is base your management decision on the long term. So not like short term based on your management decision. Even at the expense of short term financial goals. So step 2 is create a continuous process flow. Create a continuous process flow to bring problems to the surface. Step 3 is use pull system to avoid overproduction. Level out the workload. Work like the tortoise, not the hare. Principle 5 build a culture of stepping to fix problem to get quality right the first time. Step 6 standardize tasks and process are the foundation for the continuous improvement and employee empowerment. Use visual control pull system so no problems are hidden. Step 8 use only reliable through tested that serves your people's or progress or technology. Grow leaders who thought, understand the work, the life, the philosophy, and teach it others. Develop exceptional people and teams who follow your compact philosophy. Respect your extended network and partner and suppliers. Go and see for yourself to thoroughly understand the situation. Make decisions slowly by throughout consider consequences. Become a learning organization recently reflect continuous improvement. One more topic I will explain that in Toyota production system. That is the most important thing and you will completely tutorial will explain in everything. See that is the image in the Toyota production system. So welcome to the Toyota production system. So course content this is the Toyota production system and whatever in this course will there she will explain that in introduction TPS, the way of TPS, the foundational concept, the pillar and the Jidoka, JIT, quality cost and the game. Toyota production system introduction. So introduction to the Toyota production system. Toyota has repeatedly outperformed its competition in quality, reliability, productivity, cost reduction, sales, market share growth, and market capitalization. Toyota has been so widely studied and copied, however, few company has been able to match its performance. Part of the problem is that most outside are focused on the Toyota tool tactics, Kanban, pull system, card, production cell, and the like this, and not in the basic set of the operating principle. So, he'll explain that is the way why Toyota. So Toyota is the four important thing. You can see that is this principle leads to ongoing improvement in the reliability, flexibility, safety, efficiently, and hence market share and profitability. Toyota real achievement is not merely the creation of the tool themselves. It makes your work series nested with ongoing experiment. TPS is a system nested experiment through which operation are constantly improved. And the background of the Toyota Motor Corporation vehicle production system is a way of making that something referred as the lean manufacturing just-in-time system. A production system based on the philosophy to achieve completely elimination of all waste in the pursuit of the most efficient method. And this will explain that how is the background is the production system. How it will depicts Jidoka and just-in-time. We'll explain that Jidoka as which problems occur, the equipment stop immediately, prevent defective problems from being produced. Just-in-time machine in which the each process produces only what is needed and the next process continues. And I will explain that in the fully way. You can see that image, you understand about what is the background of the Toyota production system. And this is the history of the Toyota production system, the key introduction of the Toyota production system, and key value of the introduction to the Toyota production key value. So key value of the Toyota production system. The value key value act other key value work with the integrity, drive curiosity, observe thoroughly. Again, I will explain that key value of the Toyota production system. First one is say that is the key value of the Toyota production system. First one is act with other. Second one is work with integrity. Third one is drive curiosity. Fourth one is observe thoroughly. Fifth one is get better and better. Fifth one is continuous to quest for improvement. Fifth one is create room to grow. Welcome competition. Show respect for people. Think people. Thank you people. So that is the key value of the Toyota production system. So I will explain everything that is Toyota production system, and it is the very important topic. So if you found this video is useful, please like, share, and subscribe for the inspiring logic. So more video I will explain in the lean manufacturing, quality, industrial engineering, Kaizen, Kanban. So thank you for watching. Keep learning, keep moving to further process. So thank you so much.